Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we'll continue with attacking SIP authorization and this time around with hashcat. Now let's actually go to hashcat's website. Now many of you must have already heard about hashcat. It is probably the most popular password cracking and recovery tool out there. I think the biggest power hashcat has is the fact that it can go ahead and use GPU infrastructure and do the whole cracking process. Now in this video, of course, we are going to be using my weak little computer which doesn't have any NVIDIA GPUs and all of that. The key thing to realize is that the process is going to be the same if you manage to rent out any of those GPU clusters from Amazon, Azure, or even Google for that matter. Now the only reason I'm showing it on my computer and not on the cloud is simply because I really don't know the terms and services of the cloud, right? So maybe even demoing a password cracking exercise in the cloud might not be legal. So that's the reason why I'm going to use my computer. Okay, so let's actually jump in. Now you can download hashcat from the GitHub repo or from their official website. Now, I generally prefer from their official website because you can get hashcat binaries directly, especially for Windows, where you don't really want to go through a painful compilation exercise. So on hashcat's website, if you click on binary download, this should automatically go ahead and download 7-zip file which contains binaries for various platforms, and then you can extract it. I'm going to open up my command prompt. I've already done that, and let's go into the downloads hashcat folder, right? And here are all the files. So we can run hashcat 64.exe, which is really what we want, right? This is a 64-bit platform. Now, one of the important things to understand is that hashcat takes in the SIP authorization parameters in its own little format, and here's the format of the hash file. Now the good news is this is where once again our plugins come to the rescue. So I've opened the same registration success we used in the previous video inside Wireshark, and this already has our Pentester Academy VoIP custom plugins loaded. So I can click on Tools, VoIP, SIP Information, and click on SIP Auth Export. And you can see this line in here, it's a long line. Let's actually copy this out. And I can go back to my terminal and then type in echo, paste this entire thing, and put this inside a file called hash. Okay, just want to make sure I don't have any remnants from a test run I did before I'm shooting this video. Okay, so now if we look at the hash file, you would actually notice that we currently have the same line in the format that hashcat accepts, right? So we are good to go now. We already know that the password is abc12332_12331, right? Just like in the previous video. So now let's begin using hashcat. Now, if we go to the wiki, they have very detailed instructions on how hashcat can be used. So you can see that there are different attack formats. You have dictionary, you have combinator, brute force, hybrid, different ways by which you can put in rules, example hashes, right? And really, if you're interested in hashcat and doing this professionally during pen tests or red teaming exercises, I would highly recommend going through these. especially setting up probably a GPU cluster for yourself somewhere in the cloud. Now, the first thing I'm going to do is run a benchmarking exercise with hashcat. So I'm going to do a -b, and then I'm going to say benchmark for SIP MD5, right? And have a little cheat sheet in here, and the value is 11400. So I can just type in 11400. Now, what you'd find is that on many computers, you might not have the right drivers, OpenCL, whatnot, and hashcat may not always work, in which case you can actually add the --force option, right? And if you clearly notice, doesn't seem to be that anything happened here. Well, there is. We can actually see that the speed for SIP digest authentication MD5 is around 743.5 million hashes per second. That's quite a lot, as you can see. Now, if you did have any problems with this, you could add the --force. And in some cases, this would actually end up, working better. There we go. So now we're actually using both, but doesn't make much of a difference. The total still seems to be around 751.3 million hashes per second. Now, let's actually go ahead and run our attack. So what I want to do is repeat what we did in the previous video with SIP crack, and go ahead and try out all possible combinations of the character set 321_ABC. And with hashcat, we can do this using the -A option, -A3. And this is nothing but a pattern. And what this actually says is that use this character set and then construct this word, right? And you can clearly see that this is around 10. So we are going to calculate all possible combinations of 321_ABC of size 10 and try to brute force the hash for this character set. So I'm going to copy. Thank you, Windows. Okay. And what you would find now is that hashcat pretty much is done. And of course, it just depends where in the possibility, that exact ABC _12331 got created. And you would find that it ended up cracking it. And if you wanted to look at the results, there's a special file called hashcat.pot file. Always end up doing cat. There is no cat in Windows. We can do a type. And you notice at the very end, we see the password ABC _12331, right? And it has managed to crack it. Fantastic. Now, if you try to run hashcat once again, it'll immediately just exit simply because it'll say that the hash is already found in the pot file. So if you want to rerun it, make sure that you delete the pot file, and then you will be able to rerun for the same hash. Now, one of the other points I want to touch upon is you can even do full brute force without a character set. So in this case, I'm trying to brute force all 13-digit numbers. Many a times in VoIP deployments, you may end up seeing people go ahead and use numbers in passcodes. So this is going to go ahead and do all 13 digits. Of course, our passcode is 10 digits, include characters as well, so it won't crack it. But I just wanted to show you the amount of time it would take, because it will tell you roughly the amount of time it would take to go through all 13 digits. So I can type in S for status. And if you notice, it actually tells us that roughly this is going to take around 6 hours and 38 minutes, right? All 13-digit numbers, right? Not bad. I'm going to quit this. Fantastic. Now, last but not the least, you can also go ahead and use a word list like what we did in the last video. basically by using the option -W3 followed by A3 word list. Now you can try this with a word list. It does take a little bit more time to load stuff and everything, so I'm just going to leave it to you as an exercise. Now the key strength of hashcat and where it really shines is actually going to be when you go ahead and use this with a GPU, right? And that is something I can highly recommend doing. There are a lot of blog posts and videos available online on how to set that up. As I said, the only reason I'm not doing it is I'm not very sure about the terms and conditions of showing such a demo on a cloud infrastructure. So that's all I have in mind for this video. Thank you.